Correlation. Okay, so this is a question about the product moment correlation coefficient, including the correlation hypothesis test in part C. Okay, so a meteorologist believes there is a relationship between the daily mean wind speed and the daily mean temperature. A random sample of 9 consecutive days is taken and the relevant data is given in the table. Okay. The meteorologist calculated the product moment correlation coefficient for the 9 days and obtained R is 0.609. So first of all, explain why a linear regression model based on this data is unreliable on a day when the mean temperature is 24. And that's just observing that the temperatures we've got in this sample don't go anywhere near 24. So there's no point having a line of best fit, which is what this means, based on this data being extended to 24, because we've got no evidence that the same relationship between the data, the temperature and the wind speed when the temperatures are this sort of size is still going to be the same when it's 24. So all that you need to say is that 24 degrees Celsius is not within the temperatures we have in our data sample. So the link may not be reliable. Anything you calculate to do with this sample may not hold true once you get up to 24 degrees Celsius. Part B. State what is measured by the product moment correlation coefficient. Okay, this might be a question that would puzzle you. Okay, well, what you're actually measuring is the closeness of the points, the scatter diagram points, to the regression line, which is a posh name for the line of best fit. So it's seeing how good the correlation is. Okay, it's measuring linear correlation. Let's make that clear. Between two quantities. Okay, so it would only be a strong correlation value if these two quantities formed a straight line or close to a straight line as you plotted your points on your scatter diagram. Okay, the part C of the question is asking us to test at the 5% level whether basically this product moment correlation coefficient we've got here seems to be big enough to show that yes, there is correlation going on. So let's just write down what we've got here. We've got R was 0.609 and we had N9. We had 9 data points because it told us that in the question. Okay, that's all I actually need from that page. So let's move that page away. So when we're doing the hypothesis test for the correlation, we're just asking ourselves, is this R value big enough to convince me there's correlation? You probably think, well, that doesn't seem that low. Okay, the most it can be is 1, and 0 means totally, scattered points showing no correlation. So maybe 0.609 is good enough. But what we have to do is a bit more formal than that. So we start with our hypotheses. We use the symbol rho for the correlation coefficient for the whole population. R is just for this data set. So this is the Greek equivalent of a letter R. Rho. Rho is 0, is always what H0 is. So basically we're saying there is no correlation between this temperature and wind speed. it tells us we need to test whether the correlation coefficient is greater than 0. Okay, in other words, is it positive? Your H1 is always going to be rho is greater than, less than, not equal to 0. This number does not change. It's always a 0. Okay. So we've got, because it's a greater than, this is a one-tailed test. It would only be a two-tailed test if it's a not equal to, just like the normal distribution test. We're doing a 5% test, and we've got n is 9. Okay. The 0.609 is our test statistic. Okay, so our R value, that's 0.609. And then what we do is in the tables, which will be in the exam room on your desk, we look up the critical value. So this is something that's not on your calculator, but you have to look in your stats tables book, and you will see, if you go through, it's quite a way through the stats tables book, table 9, critical values of the product moment correlation coefficient. Okay, the table goes longer, but we don't need more of it. We just need to find the correct column. So we want one-tailed 5%. So there's one-tailed 5%. You go down that column and you go as far as 9. Okay, and we just write down that number, 0.5822. So basically, we just need to be this value or bigger to then show H1. Okay. The idea is that you have a scale of correlation stretching from -1 to 1, with 0 as being no correlation. So it's going to cover positive correlation and negative. Our critical value was at 0.5822. Anything from that value towards the side, whichever side you're on, is what we call the critical region. So as long as your test statistic falls into the critical region, which ours does, then we can reject H0. So it's exactly the same as the critical region method that we were using with the normal distribution test. If you fall into the critical region, you can reject H0. Okay, so here we can say this is showing evidence of positive correlation between, let's do it in context, temperature and, what was it, wind speed. Okay, so that would mean, interpreting that would mean that on hotter days are more windy. I don't know if that is generally the case, but that's what this data seems to show. Okay, because we've got positive correlation between temperature and wind speed.